we have something called k-fold cross validation. What is cross validation? When you apply the trained model on the test data set, you will get to know the prediction, right? What is prediction accuracy with the help of root mean squared or mean squared error. We will get to know that. Okay. So now what we did here, we applied the model on the unseen data using the predict function, okay, or method. So, and then we stored the predicted values for the unseen data in this variable pred. When you type pred and execute it, it gives you the predicted or estimated housing price. Okay. So, and then what we did, we just use the root mean squared error, right? So here mean squared error, we just passed the actual value and the predicted value. Okay. And what it does is it gives me the root mean squared error. Okay. So the lesser the error, better the model. That is what we discussed. Now the question is, if I use this test data, I am getting this error. What is the assurance if I use another test data, will the error remain same? Okay. For example, I'll give you another example. See here, this is my model, right? Linear regression model. You have trained your model. Let's when I apply the model on the training data set, the error, let's assume that the error is 2. Let's take the same thing. And test data set, when I apply this model, what is the error? This is your root mean squared error. Okay. This is my training data, test data. Here I'm getting, let's 2 or 1.98 RMSE, root mean squared error. Okay. That means when I apply the model on the training data set, this is what root mean squared error. Test data also somewhat close by. So this error, that means my model error is more or less same, even if I apply on the training and test data set. என்னன்னா தெரிஞ்ச ரோட்ல வண்டியை ஓட்ட சொன்னா நல்லா ஓட்டுறீங்க, அதே தெரியாத ரோட்ல ஓட்ட சொன்னாலும் நல்லா ஓட்டணும். தெரியாத ரோட்லயும் நல்லா ஓட்டுனீங்கன்னா, தெரிஞ்ச ரோட்லயும் தெரியாத ரோட்லயும் வண்டியை நல்லா ஓட்டுனீங்கன்னா, தட் மீன்ஸ் யூ ஆர் எக்ஸ்பர்ட். நீங்க மக்கப் படிக்கலன்னு அர்த்தம். புரிஞ்சுதா? This is the principle here. Okay. So the model, how well the model generalizes. How well my model generalize, that is more important. Okay. Okay, we train the model, we applied the trained model on unseen data, and then we use the metric like root mean squared error and adjusted R squared. Everything is good, and I just checked the model assumptions. I validated all the assumptions are met. Cool. That doesn't mean my model is doing great job. Can you say that? Wait. Okay, Baba, if I use this test data set given by Fahima, right? So my model performs somewhat close by this. Listen, my Deepthi gives me another data set, test data set. She gives another. Now she is challenging me. Boss, you applied your model on the training data set. It is fine. But when you apply the model on Fahima's data, test data set, it gives me this one. But why don't you apply the model on my test data set and you tell me what is the error? If the error is 0.8 or 0.60, now is the biggest question. Everyone will be in confusion. Okay. So they don't know which one to remind. So this is called cross validation. Applying the trained model. இதெல்லாம் அப்படியே ஞாபகம் வச்சுக்கோங்க. திருப்பி வீடியோ பார்த்துக்காதீங்க என்ன. So when you apply the trained model on the unseen data, that is nothing but, or training data when you apply it on the test data set, which is nothing but predicting the test data set using the trained model, that is called your cross validation. But in this case, we are using only one test data set. Now what she says, with this test data set, my error is 1.8. So both of them are somewhat closer. That means my model performs well. எந்த ரோட்ல விட்டாலும் வண்டி நல்லா ஓட்டுறான் அப்படின்னு தெரியுது. எங்க என் ரோட்ல ஓட்டு பாருன்னு இந்த தீப்தி சொல்றாங்க. Now Deepthi, you know Tamil, right? Okay, please bear with me, I have some freshers. Okay. Okay. And now if I apply the model, இதுவும் somewhat closer to 1.97 or 2.0 வந்தா okay, but 1.60 வருது. So too much of variation. Now everybody is breaking their head. How can we say my model is generalized well or not? That is where we have something called k-fold cross validation. K-fold cross validation. 1 second. K-fold cross validation. Instead of using only one test data set, we are using more than one test data set. K-fold cross validation. We know what is cross validation. Now we are going to extend our knowledge with k-fold. Okay, k-fold cross validation. The k is dynamic. It can be a 10-fold cross validation or it can be 5-fold. Usually they use 10-fold. Or let's, for example, sake for simplicity, we'll take 5-fold cross validation. Here, for example, you have 500 records, 5000 records இருக்குன்னு வச்சுக்கோங்களேன். Now 500 records இருக்கு. 5 folds இருக்கு. 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. So here it will distribute, divide this itself another 5 folds. Okay, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right off. Each given data so given 500 records and you are using 5 folds, it equally divide these 500 records into 5 rows and 5 columns. Okay, இங்க பாத்தீங்கன்னா each rows 100 records இல்லையா? Each row 100 100 100 100 and then இங்க each row 100 but each column எவ்வளவு வரும் இங்க? 25 25 இல்ல 20 20, right? 80 100. Similarly 20 records 20 records 20 records 20 records 20 records 20 20 20 20 20. It will take care of it automatically. All you need to use some functions. It will divide this data, split this data equally like this, almost equally like this. So in this case, what it does is it uses the first 4 the cell values for the training data set. Remaining one test data use பண்ணிக்கும். நம்ம கிட்ட இருக்கிற ரெக்கார்டு 500 ரெக்கார்டு தான். Since I mentioned 5-fold cross validation, behind the scene it splits the data like this, 5 rows 5 columns இந்த மாதிரி பண்ணிக்கும். இதுல 4 columns training purpose-க்கு ஒரு column test data set யூஸ் பண்ணிக்கும். அப்புறம் when it comes to the next set of data, right, what it does is it uses the 3 4 5 4, right? It uses these combinations for training. Sorry, here okay, let's say இந்த மாதிரி வெச்சுக்கலாம். Okay, இந்த மாதிரி வெச்சுக்கலாம். Okay, இத ஒரு ட்ரெய்னிங்கா யூஸ் பண்ணிக்கும். இந்த ரிமைனிங் ஒரு செல்லுல இருக்குது டெஸ்ட் டேட்டாவா யூஸ் பண்ணிக்கும். And then here also what happens is in this case it uses these 4 cells as a training set, and this is the one it uses for test purpose. Similarly, it does the same thing. Okay, so what happens is with the given data set itself, it creates 5 different partitions with equal size, almost equal size of the values, records, okay, in each partition. And then what it does is it considers the first 3/4 as the training data set, remaining as test data set, and it leaves the first one in the second case, and then rest of them it considers as a training, and then rest of the remaining one it considers a test data set. Same thing is applicable across the rows. So each fold it uses different training and test data set. Do you all agree with me or not? புரியுதா? ஒரு பார்ட்டிஷனுக்கும் ட்ரைனிங் செட்டும் டெஸ்ட் டேட்டா செட்டும் டிஃபரெண்ட். புரியுதா? இந்த மாதிரி எல்லாம் புரியுதான்னு கேட்க மாட்டான் வெள்ளைக்காரன். நான் சாவடிச்சு வருவான். கான்சன்ட்ரேட் பண்ணி டக்குன்னு புரிஞ்சுக்குவாங்க. இவ்வளவு டீட்டெயிலாக எக்ஸ்பிளைன் பண்ண மாட்டான் அமெரிக்கன்ஸ். Sorry guys, those do not see. So what I said, right, understand, concentrate here, understand it pretty fast manner. The understanding, is very much IQ. So right, understood, right? So for the same data set, it divides into different set, different partition, 5 different partition. Each partition in this example, 100 records it was. And again, it splits this into 5 equal parts. And each part has 20 records. 5 into 20 is 100. So I have only one linear regression model. My model name is model, right? So my model will run against these 5 different partitions with different training and test data set. With each iteration, which means each partition, what is the error? Root mean squared error. Training and test error. For example, test error எடுத்துக்கலாம். Test error இங்க 2.0 வருது. இங்க வந்து 2.02 இருக்கு. இங்க 2.07 இருக்கு. 2.60 இருக்கு. இங்க வந்து let's say 6.0 போச்சு. இது வந்து you need to take the mean and then standard deviation. இது வந்து ஆபீஸ்ல சொல்லி கூட தர மாட்டாங்க சீனியருங்க. Once you join as a fresher, they will not teach you all the things. தெரிஞ்சுதா? அவங்க என்ன சொல்றாங்க, ட்ரைனிங் சொல்லி கொடுக்கலையா, நீங்க படிக்கலையா அப்படின்னு. நீங்க படிக்கல, அதை சொல்லுங்க. ஏன் நெட்ல இல்லையா அப்படின்னு ட்ரெயினரை பிளேம் பண்ணணும். இல்லைன்னா நெட்ல இருக்கணுமா. ஸோ இங்க வந்து யூ நீட் டேக் த மீன் ஆஃப் ஃபார் ஆல் தி எரர்ஸ். ஏன்னா ஒவ்வொரு பார்ட்டிஷனுக்கு ஃபார் ஈச் பார்ட்டிஷன் த ட்ரைனிங் அண்ட் டெஸ்ட் டேட்டா செட்ஸ் ஆர் டிஃபரெண்ட், isn't it? Obviously the error will also be different, but if all the errors are somewhat close by, that means there is not much variation. That means எந்த ரோட்ல விட்டாலும் இவன் நல்லா ஓட்டுறான்ப்பா அப்படின்னு கன்க்ளூட் ஆயிடும். இங்க இப்படி வந்ததுன்னா வந்து டெஸ்ட் வந்து கார் டெஸ்ட் வந்து உங்களுக்கு ஃபெயில் ஆக்கி விட்டுரும். இந்த ரோட்லாம் ஓட்டுறாங்க, இந்த ரோட்ல சரியா ஓட்டலாப்பா, போய் வேரியேஷன் நிறைய இருக்கு. ஸோ ஸ்டாண்டர்ட் டீவியேஷன் அண்ட் மீன் யூ நீட் டேக் ஆன் தி எரர் ஃபார் ஈச் ஃபோல்ட். You need to take all the false errors mean, all the false errors standard deviation. Higher the standard deviation, that means the variations to your model is not generalized well. Lesser the mean error or lesser the standard deviation, that means your model is performing well with the different training and test set. Now we can go ahead and deploy it in production. Production or live system. அதை அப்புறமா எக்ஸ்பிளைன் பண்றேன். Are you able to follow me or not? How many of you are able to? Can you make it fast here? Don't to please me, don't tell I am able to understand. Sai Sudha is crystal clear and she says excellent explanation. Okay, Soundarya, you are able to understand. Swarna, you are able to understand. Praveen, you are able to understand. Deepthi, very clear. Okay, how about others? Dhanraj and Shriram is not at all logging in. Fatima and Jay Prashant is, guys, the interview is not in my, I'll tell you, so now you understood what is K4 crossover. So in today's session, we have covered comprehensively what is cross-value and what is the entire model, right? Right from training the model to fitting, performing cross-validation and also linear regression assumptions. And also we have seen what is K-fold cross-validation. What is cross-validation? What is the difference between cross-validation and K-fold cross-validation? Cross-validation, we are doing it with only one test data set. With K-fold cross-validation, we take the given data set. Within the given data itself, we are creating 10 folds. Okay, and 10 folds. And then each fold, it considers one set of data as training and the one set of data as a test data set. With a different training and test data set for each fold, it fits the model and finally it gives us the scores. Scores are nothing but, in this case, R squared. You take the standard deviation. The standard is less. In fact, it is good, right? And whereas here, if you see here, here we have taken negative mean squared error. We multiply this with -1 because we want to convert some +1. Next order STD, it gives us the standard. So the error is, there is a variation, but it is not too much. But How do I know if this standard deviation is too high or too less? 1.44 itself less, but how can I say it is less, very less or less? So for that, you need to use different combination of the input features. இங்க வந்து நம்ம இத கணக்குல எடுத்துக்கிறோம். நம்ம இதுதான மாடல் யூஸ் பண்ணியிருக்கோம். இதுதான் மாடல் நம்ம கொடுத்திருக்கோம். இதுதான் I'm talking about this one only model, right? In the X-Train, I have used size and UDS I used it. Okay, and you try with this one. Okay, and first you try with this, and then what is the variation here? Okay, and then you try with the second one. Note down, and whichever things gives us lesser the variation with respect to error and R squared also lesser variation, that means that is the best model. Okay, for example, if a second model size plus UDS மட்டும், when I use only those two features, if the error is compared to this one, right, very less, and R squared is variation also less, the error variation also less, that means that model, and then we conclude that we deploy it in the production environment. Okay, any questions so far? Okay, Ramya, sorry, Sai Sudha's question is, with the K-fold cross-version, can we decide and publish it on cloud? See, there are various other factors. Okay, that we will discuss it in tomorrow's session. Okay, here we have taken the data set directly and then we trained it. Okay, and the general rule of thumb is first we do the model selection, whether linear regression model. Okay, let's say you have used all the 4 independent variables and your variation is a little bit more. When you use the independent variables which are significant, the size and UDS. Size and UDS, your model error variation is less, good. That doesn't mean we directly deploy it on cloud. Okay, so what our production? So what we do, we try with different models, like regression models, like we have XGBoost and we have neural network. Everywhere we fit it, and we will see, of all the models, which algorithm accuracy is more. No, Sai, Sai Sri, we cannot generalize which algorithm will be. So you need, it's a trial and error. That's all. Okay, you need to try with everything. Huh? What is that? Trial and error means, can I fit all the algorithms to? Yes. Obviously. See, if one algorithm is itself doing good job, then why do they need to recruit you? Why do they have to pay more to data scientists, right? You need to fit with neural network, you need to fit with XGBoost, all the algorithms, like what is that? Light gradient boosting, and then only we decide. Okay, guys, since you don't have any questions, we will continue in tomorrow's session. Tomorrow we will discuss about the assignment, linear regression model assignment. Okay, you watch this, you take the script, and we will re-upload the script again, and you consider this the latest version. And just beneath the linear regression video in our portal, you'll find the script. Okay, and you download this script, and tomorrow I'll explain you the assignment. Same housing price prediction. You will have data, everything is available on our website, but only thing is more number of input features will be there. Try with that one. Okay, and then we will see how well you are fitting the model. The internet, lot of scripts are available.